The purpose of this video is to help you find the volume of prisms and the volume of cylinders. Remember, volume is the measurement of how many identical cubes of a given size fit into a three-dimensional shape. So first we'll start out answering the question, what is a prism? A prism is first a three-dimensional figure. A prism has edges that are line segments, and a prism has two congruent parallel bases. In the picture, the two yellow rectangles are the congruent parallel bases. The formula for calculating the volume of a prism is volume equals capital B times H, where capital B stands for the area of the base. In this case, that would be the area of the yellow rectangle, and H represents the height, the distance between the two yellow bases, or how tall the three-dimensional figure is. The next question, what is a cylinder? A cylinder is a three-dimensional figure. It also has two congruent and parallel bases, but what makes a cylinder different than a prism is that a cylinder has bases that are circles. As you can see in the picture, the top and bottom of the cylinder are yellow and they are circles, and those are the bases. If you want to find the volume of a cylinder, you use the same formula as you do when you're finding the volume of a prism. There's one slight difference. So you start out with the formula V for volume equals capital B times H, where capital B is the area of the base and H is the height. The difference is that now the base is a circle. So when you find the area of the base, you need to find the area of the circle, pi r squared, and then multiply it times the height. So the formula for the volume of a cylinder is V equals pi r squared H. Now for a volume of a prism example. You can see here we have a picture of a prism with some dimensions labeled. The base of the prism is a rectangle with dimensions 8 by 5. The height of the rectangle is 9. The formula for finding the volume of a prism is V equals capital B times H, or volume equals the area of the base times the height. First, for the area of the base, we have a rectangle with dimensions 8 by 5, so the area of the base is 8 times 5, or 40. For the height, we have a height of 9, so the area of the base is 40 and the height is 9. So the overall volume is the area of the base, which is 40, times the height, which is 9. 40 times 9 is 360, and the units are centimeters cubed, or cubic centimeters. This means that our box could hold 360 cubes that were 1 centimeter by 1 centimeter by 1 centimeter. Now for an example showing you how to find the volume of a cylinder. The picture shows a cylinder with a base that's a circle that has a radius of 8 and a height that is 6. Our formula for finding the volume of a cylinder is V equals capital B times H, or volume equals the area of the base times the height. The difference in this problem is that now our base is a circle. So when we go to find what the area of the base is, we have to multiply pi r squared and then multiply that base times our height. So as you can see in purple, I've taken the volume equals pi times 8, which is the radius, squared, times the height, which is 6. And when I multiply 8 times 8, I get pi times 64 times 6, which for an exact answer would be 384 pi centimeters cubed. If I want to find the answer as a decimal, rounded to the nearest hundredths place, I use my calculator and type in 384, and then I hit shift and hit the pi button. And when I hit the SD button after that, the rounded off answer on my screen will be 1206.37 centimeters square or cubed. That means 1206.37 cubes that are 1 centimeter by 1 centimeter by 1 centimeter will fit into our cylinder. In our final example, we are going to try to find the missing dimension from our cylinder. In the problem, it tells us that the height is 20. It tells us that the volume is 1005.30965 meters cubed, and they want us to find the radius. So we go to our formula for finding the volume of a cylinder. V equals capital B times H, or V volume equals the area of the base times the height. And we replace the capital B with the area of a circle formula. So now we have V equals pi r squared times the height. And in the problem, they gave us the volume. So we'll replace the V with 1005.30965. Pi will remain in our equation. We'll replace the radius with, no we won't, the radius will be our variable. So we will have an r in our equation, and we'll replace the height with the number 20. So our purple equation has a variable r. We need to divide by all of the things that are on the same side of the equation with the r in order to find out what the radius is. We will start by dividing both sides of the equation by pi, which leaves us with 320 equals r squared times 20. Now we will divide both sides of the equation by 20, which leaves us with r squared equals 16. Now to change our r squared into an r, so we know what the actual radius is, we need to take the square root of both sides of the equation. The square root of r squared is r, and the square root of 16 is 4. So the radius of the circle, which makes up the top of our cylinder, is 4 meters. Now it's your turn. Find the volume of the prism shown in the picture. Find the volume of the cylinder shown in the picture. Find the missing dimension of the cylinder. And in this cylinder, we know the radius and we know the volume, and the missing dimension is the height. So find the height of the cylinder.